Okay, let me know when you think we have everyone has picked a group and has joined us.
Let me give it another second. I think we had about 40-ish people in the overall room, so give it another minute, a couple seconds. Yeah, I think you can get started.
Great. Thank you everyone for joining room 2. As Jenky said, we're going to be looking at Revit Autodesk Insight, and what sometimes I refer to as early energy modeling, but I've been starting to call it massing and orientation analysis to help the misconception of that this is not detailed energy modeling. So I'll just jump right in. This group, I'm from the Baltimore AI office, but I'm happy to be here with the Philadelphia folks, and it's called the AI 2030 Working Group, right? So we're all working to this path to sort of zero energy and this energy reduction. So I always like to sort of show this slide when I talk to clients or to groups. And today we're really focusing on this very first section, right? Rethinking orientation and massing. And this is all sort of simple stuff we probably learned somewhere in architecture school about, right, how the sun moves around the building and how orientation of the building will actually affect energy usage. And talking to clients and projects, we always say, well, the earlier you can integrate sustainability into the process, the more impact you can potentially have. And then I always say, no, we need to start even earlier. No, right, even earlier than that. Whenever you think it's already kind of too late. I have one client, and the image on the left, they came to us with a concept layout plan from the civil engineer, and it was already approved. And this client is interested in zero energy. And of course, I brought up, can we change the building just a little bit, right? Can we make some orientation? You can see the footprint is basically the same, a couple of different orientation changes. In the end, we weren't able to make that change, right? It was already approved before it even came to us. And they were like, but this is early concept. But at that point, we had already missed out on this opportunity to save almost 10% energy efficiency. So I'm going to now just sort of back up, and I don't know how many people have used Revit Insight, or I didn't really plan to do a poll, but basically these little squares, once you go into Revit Insight, these are all the programs, projects that I have run in this program. And so this is one project where I've done a couple of different options, and it's a little confusing. I'm not going to lie, because you see EUI max, EUI min, EUI mean. You can compare using net zero, architecture 2030, some favorites, some custom. And then what happens is you go into a project and you see, I don't know, 28 different things that you can sort of change the variables of. And I call this the Revit Insight rabbit holes, because you can get lost in here very quickly. And this is where people sort of get to that point and they're like, oh, it's too much information. What's the mechanical system? What's the R value? What's this? And if you remember, right, we're trying to do this in concept and layout. So you don't actually know all of these answers. So what I try to tell my teams is just accept all the defaults. You have to answer that one question, where in the world am I, right? Pick your location and you pick your project type. Everything else, just we accept all of the defaults, because you cannot get caught up in all of those things with this single aspect analysis. And this is one example right here, building orientation. So the example on the left is what happens when you first click on your project. And then, hold on, let me move our little heads to the other side. The example on the right is I can move these little arrows around. But what did I actually do? So in Revit Insight, you see that this EUI went from 64 to 60. But what am I taking out of this task? I'm not sure. So what I tell my team to do is to, once you have a project with different schemes, you check the little boxes, you export a a table and you get a plain old good Excel file, right? So if you're data analysts and sustainability experts or engineers, modelers, you don't mind looking at an Excel file. And the only thing we want to look at is this ASHRAE 91 column. You can see there's an architecture 2030, and you might be tempted to look at that. But I think this column is telling you what Revit Insight thinks your EUI should be if you're meeting the 2030 challenge. Then there's this mean, max, and min, which I still haven't figured out. And then there's the cost, right? We don't want to get into the cost. We'll talk about that more in the disclaimer. So I like to use this ASHRAE one, because to me, this means that is what Revit Insight thinks your building is doing if it is just built to code. You can also, from this Excel file, then check your sort of building area, and you can say, why is scheme 2, you know, you want to just make sure they're all about the same square footage of the schemes. From that point, I made a sort of custom Excel calculator for my team, right? Please fill in the yellow squares with the EUI numbers. You're going to pick one scheme as your baseline. You put in that EUI number. You put in the other EUI numbers. And then I'm only talking about a percent change. So I don't want to tell my client, right, the EUI is 230 or that I'm predicting their actual energy consumption. And you'll see on the bottom of all my slides, I sort of made up this little sentence. And then from there, all I'm talking about, this is an example we did for an interview, right? We had 3 schemes. Here's my baseline, and this one's 12% more energy efficient. This one's 14%. Now, a little tip that I do is, you might see one slide where I didn't do this, but I always take my worst energy performer and make that the baseline. So then every scheme is sort of better. You don't have a scheme that's negative. Now, you can do it however you want, right? You can try to make if you want your preferred scheme to look the best, you can sort of play around with which is the baseline. But I find this kind of works. If you pick the lowest, I mean, I guess it would be the largest EUI as your baseline and go from there. So in this example, right, we've looked at 3 schemes. We assumed a window wall area ratio of 40% in the Revit model before we went to Insight. Then we wanted to say, well, what if these schemes, what if all the window to wall area ratio was 80? I did not do that in Revit Insight. I've tried, right, using those little things and sliding them around, and it just changes everything. It's so much easier to go back to Revit, change that one default in Revit, and then resend those 3 schemes to Insight. And then you can compare them with different window to wall area ratios. So any questions there? Or I have a couple other examples to show, but I just wanted to stop there if you had any questions thus far.
I have one question. So you said that you went back into Revit and changed the window to wall ratio. Is that the setting in the model that's talking about window to wall ratio, or you changed like the physical amount of glazing in that model?
That's a really good question, and I forgot to mention something important in the beginning. All of these are using massing elements in Revit. There's 2 different ways to use Insight. One is with massing elements and one is with building elements. So the assumption is that all of these are massing. Now, even if a project team has developed it further, right? They have real windows in and, you know, it's so much easier to spend 10 minutes and do a quick massing model. Because when you try to do the building elements, again, you have to make all these decisions that we're really not ready to make at this time. Because the only thing we want to find out is option C more efficient than option A, just based on orientation and the amount of windows per each. So it is going back to the massing model. And then from there, you just go into the attributes of the model and you change one number. And that's how you change the window to wall area ratio. That's a good question. This next scheme, this is an example. I get if I ever get sort of pushback on trying to integrate this in, it's, well, in housing and mixed use projects, we don't have options to have 3 different schemes, right? The developer's building out to the site limits. That's true. But in this example, what we did was we started alternating the window to wall area ratio on each of the facades. So in this example, the thick line, wherever the thick line is, represents a 40% window to wall area ratio. And then the the regular non-thick line is 80%. And you can see this is the example where I said that I have a negative 18%. And you can see, right, this at southwest, 80% glazing on southwest is 18% less energy efficient than if you did it this way. Now, this project is in Baltimore. It's on the waterfront. Guess which direction has the view? Southwest, right? So we're not always, as designers, we're not always going to say, well, no, we're going to take this one, because you're not always going to pick the most energy efficient. The developer may pick this one, or maybe it's some combination of, this one and that one together. But if you pick that decision, right, you're going to have views to the Inner Harbor. That's just what we do here in Baltimore. But how do we deal with that, and how do we move into the next phase of design with making some adjustments to make up for that energy loss? This next example, again, you can just look at the first two boxes. It was a feasibility study, right? And we had, we could orient the building this way, orient it that way. And you can see it's not much different. We had a feeling we were going with this option B. So again, we sort of did, well, what if we optimized it, right? And we again played around with window wall area ratio. It got 5% better. Then this project went on, right? So this is our preferred scheme. This project example of how it started with a feasibility study. Okay, then we win the project. Now we picked a scheme. And then we thought, wait, what if we went to a 9-story building instead of having 2 5-story wings? 10% more energy efficient. We went with that scheme. Great, okay. So now we took the scheme we're now going with, and then also similar to that previous example, we looked at, okay, what if all sides are code? What if just the short sides are 75%? What are the long sides? And you can see the point here was to make to the designers and to the clients that, again, orientation was not great. East to west are the long sides. So again, you might think, oh, that's horrible. But this is how it really worked with the campus planning, and what just all the other variables that you cannot measure with the energy modeling, which led the client to go to this option. So this was just, again, another way to sort of inform design decisions. My last example is a client, and this is the one I showed in the very beginning. It's a senior living client who really wants to get to zero energy. This is the example I showed before. Sometimes this is what we show them. It's just a quick mathing. Sometimes it doesn't make that much of a difference. Sometimes it makes 2%. This was a little bit of a more detailed, where we looked at 5 different schemes in energy efficiency. Oops, I think I'm missing a slide. And then we also looked at solar exposure to put PV on the roof. So those were sort of layered together, and we picked the best option for energy and for solar.
Good. Thank you.
This is another example of how we might show it in a RFP proposal, right? A little more fancy, and some of those heating load charts that are there to sort of look at for additional information. And this is where the early energy sort of stops for me, at this orientation. And at that point, that's when I work with my detailed energy model to look at envelope, which is, right, that's session 2 of this meeting, systems, controls, and then lastly, renewables. And these are all the things we kind of look at. And in residential senior living, we take lighting and we divide that into exterior lighting, interior for the common areas, and for the units. And then we have a really sort of detailed spreadsheet where we work with the energy modeler and the cost estimator to compare the energy cost savings to the first cost savings. And that is my last slide.
I think we had one question in the chat about how did you generate these charts?
The which chart was that?
I'm
The one-
guessing probably like the last 2 pages.
I think it was the
This
previous
one as well.
slide. Yeah.
Oh, this one?
I think
This
go back one. I think it was one slide before this. Yeah, this one I think is when they asked the question.
Okay, this one was it was a really old example. It might have even before we had Revit Insight. It was when they actually gave you, once you ran the analysis, it gave you like a 25-page report. So I'm assuming you can still get to these heating and cooling loads in there. Again, now all of the slides that I showed previous to this one, I actually don't want to get into this much detail with the client at that early stage. This pie chart I got from my energy modeler, and it was specific to that senior living client. So they could really look at what lighting means to their buildings. They actually have heat lamps in their project. So we had another thing where it's like, that's not a code minimum. If you take the heat lamps out of your project, you save 5% like that. And you have to start asking those questions that might not normally be asked. They're like, but we've always, one of Jenke's, right? But we've always had heat lamps, right? Okay, well, if you ask a senior living client moving in, like, would you move into this place without a heat lamp? That's one question. If you ask somebody who already has one, do you want to give it up? They're probably going to say no. But would a new client not move in because they don't have one? Probably not. So again, it's sort of how you ask the question of whether you really need that amenity.
We also had another question about, in the last step, the cost estimate and energy model. Do you use the energy model to consider operational / life cycle costs?
So this is a good question. This is sort of set up. Not only is it set up by the sort of the order of, it was that sort of is reminiscent of that arrow that I had of energy reduction in the beginning, but it's the things that sort of have the longest system life. So if you're talking about your walls, once you build your walls, you are probably never replacing those walls again. So an investment in energy efficiency in your wall can probably have a longer payback because that wall probably has a 50-year, 100-year life. When you're talking about lighting might only have a 20-year life, right? So it's important to think about how long that system, that single aspect system, is going to last in the building. And at the bottom of this chart, right, we have renewables all the way here at the end. And then we have these combinations. So we always do one, right? What is the code baseline? Like, what if you just built the code? What is the best performer? Which is the best payback? What's some other combination you want to put together? Sometimes we have the closest to zero energy, things like that. So you might take a wall improvement that might have a 20-year payback, which you might think, oh, that's horrible. But when you add that in with 5 other system changes, that combination might only have a 5-year payback. And so that's why it's important to sort of look at things separately, but then also look at those combinations together. Did that answer that question?
Yes, thank you.
I have a question about Insight specifically. So you use Insight kind of up until that building orientation, window to wall ratio point, and then you move on to something else. Is that usually the process?
Yes. So we do it super early on with just layout, and then we can use it a little bit more when we're trying to work with the design team about thinking about windows and placement. But from that point on, we will then go to the energy modeler. So I never fill out, R values in Insight, window, U values, solar heat gain. I'm accepting the default mechanical system for a K through 12 school. and whatever the default is for operating hours. Because any one of those things that I start to change, I can then sort of get lost down the path, and then I lose the thing that I originally wanted to do. And you can see here within my details energy, I'm looking at 3 different HVAC systems, right? I'm looking at code lighting and what does it mean if I reduce that LPD by 20%, 35%. This is sort of a generic version that I'll send out to the design team, and then we'll have a detailed meeting with the energy modeler, the mechanical, electrical engineers, where we actually fill these specific things in. I'm sorry. I was trying to scroll in my chart, but so, and again, the code baseline, whether this is senior living or higher education, K through 12, right? All those baselines will change. And then you also need to know if you're comparing it to the energy code, or if you're following LEED's energy baseline is always a little bit less. So for me, I always care about the energy code first, because that's what incentives are kind of tied to. And then LEED is always just extra. But sometimes that has to be 2 models. Sometimes if something will get you extra LEED points, that will get you to gold, which will get you tax incentives. So it's always important to sort of track both. But energy modelers will tell you, you got to pick one baseline to start, and then you can build the second model and make those changes.
And so do you typically model a detailed energy model for all of your projects, or is it like all of your projects start in Insight and then maybe depending on how the project progresses?
I would say, I would love to say it's 100% of my projects are energy model, but I can't. That's the goal, but it just doesn't happen. All of schools in Maryland, if you get state funding, you have to do LEED, some certification. So I can say probably 100% of my schools that are state funded are energy modeled, because we have to follow some sort of path and prove energy efficiency. I might say, I don't know, maybe half of senior living and housing projects follow some sort of rating. But unfortunately, it's really driven by the jurisdiction which the developer is working. And if they can get an incentive or a boost for doing it, then they'll go down that path. The incentive, that, you know, the carrot and the stick is, if we can, and I'm sure you guys have this in Pennsylvania as well, if your utility provider provides incentives to do energy modeling, increase efficiency, the client can then get money back. That's a property, so there's property tax credits, and then there's utility rebates. So again, the senior living client that I mentioned is really interested in free money. Some other people don't think it's worth the time. I haven't sold it well enough to those clients. So it's always just, I would love every project to do this, but it's still very hard to talk people into who just do not want to do it.
Well, it looks like we have about 30 seconds left. I'm not sure if it's going to push us to a 1-minute warning, but if anyone has any last minute questions, or if Lisa, if you want to close with anything, feel free.
No, I think I will stress what I think I was trying to stress in the beginning is, the earlier you can start this process, the better influence you will have. So many projects, I think, skip that first step because they've already picked a scheme and they've already missed that opportunity. So the earlier you guys can do this, the better it will be for your project and for the client.